Hello everyone, welcome back to another Zulu Alpha Aviation video, and in today's video we talk all about pressure altitude. Stay tuned. So before we get into pressure altitude and all of those things, we need to understand how pressure works in our atmosphere. So when we think of ourselves on the ground, there's altitude above us, or air above us, and air, believe it or not, has mass. Now the best way to think about this is to think of a column of air above you. So when we look at someone standing at 0 feet above sea level, there's way more air above them than with someone standing at 4,000 feet above sea level. So we call the weight exerted on the ground the atmospheric pressure. So given that the higher you go, the less altitude is above you, we can then say that the pressure reduces as you go higher. It is generally understood that atmospheric pressure reduces with 1 hectopascal for every 30 feet increase in altitude. It is also a rule that the standard sea level pressure is 1013.25 hectopascals. So therefore, if standard atmospheric conditions exist, the pressure at 30 feet above mean sea level would be 1012.25 hectopascals. So pressure altitude then becomes important as we calculate a lot of performance values from this. An example would be the time, distance, and fuel to climb graph. We use pressure altitude in these graphs because the pressure altitude will be the altitude at which the aircraft feels like it's performing at. So you can now understand that pressure altitude plays a vital role in the aircraft performance. Now, how would we calculate pressure altitude? To calculate pressure altitude, we need to write down our rules. Firstly, remember that 1 hectopascal is equal to 30 feet of altitude, and the standard sea level pressure is 1013.25 hectopascals. Let's give you the following example. The airfield elevation is 3,000 feet above mean sea level, and the QNH, which is pressure at mean sea level, is QNH 1024 hectopascals. Note, this information can be obtained from air traffic control and the METAR. Now we need to work out the difference between our QNH and our QNE, or 1013.2. So 1024 subtract 1013.2. This is equal to 10.8 hectopascals. Now convert this value into feet by multiplying it by 30. You'll get an answer of 324 feet. Now there is some confusion that may play into the following part, but this is what to do next. Because our QNH is higher than the standard, our aircraft will have more atmosphere at the airfield elevation. In other words, the aircraft will feel like it's at a lower altitude because the pressure is higher, or there are more air molecules where the aircraft is. So we subtract 324 feet from 3,000 feet. This will give us a pressure altitude of 2,676 feet. Now if the QNH was lower than the standard, we would do the exact same, but we will then add the values and not subtract them. Thank you guys so much for watching. I really hope you guys enjoyed that video. I did take this video down before because I actually made an error in the previous video, and that was specifically with adding and subtracting the values with regards to pressure altitude. Please don't get confused with adding or subtracting. It really does confuse. Even if you think you understand it, I promise you within a month of you not doing it, you will get it wrong. So just, practice it every week. Make sure you understand what you're doing. And yeah, I'll see you guys in the next video. Please like, comment, and subscribe. Bye for now.